Hi and welcome to maths class. Today we're looking at trying to find the derivative of circular functions, and I'm going to show you how that works. So what we're starting with today is what you can see in front of you is the sine function y equals sine x, and you can see that along my x-axis the axis is divided up into pi and 2 pi and multiples and fractions of pi. So the sine function, just a quick bit of revision, the sine function passes through 0, 0. It reaches a maximum at pi on 2, 1. It goes back to 0 at pi. There's a minimum at 3 pi on 2, negative 1, and then it goes back to 0 at 2 pi, and after that the pattern repeats itself. So what I want to look at now is what does the gradient of the sine function look like. So I'll just start by sketching a little secant there. Now this is not exactly the gradient, but it's very close to the actual gradient that we see on the sine function. And in actual fact, the gradient at that point on the sine function is 1. So when x equals 0, the gradient is 1. Okay, now if I go somewhere up here, I can see that my gradient is starting to get less steep, but it's still a fairly positive, strong, steep gradient. Now when I move to x equals pi on 2, I have a turning point, which means that when x equals pi on 2, I have a 0 gradient. It's a horizontal gradient. Let's go down and have a look at what happens at x equals pi now. This gradient at x equals pi actually reflects the gradient at x equals 0, but it's negative. It's the same steepness, but negative. And in actual fact, the value of that gradient is exactly negative 1. Let's head over to 3 pi on 2. You can see that this is a minimum point. It's a turning point. It also has a gradient of 0. And then when I head over to x equals 2 pi, this is exactly the starting point of my cycle. I'm starting a new cycle, so I'm back to x equals 1. All right, so what if I wanted to make a graph of x, the same x values, but instead of y values, I'm going to have the gradient values. And that's exactly what you do when you graph a gradient function. Instead of graphing x against y, you're graphing x against the gradient of the graph for that x value. So for an x value of 0, I saw that this graph has a gradient of 1. Then over here, when x equals pi on 2, my graph has a gradient of pi on 2. When x equals pi, my gradient I found was negative 1. And then when x equals 3 pi on 2, I'm back to a turning point, which gives me a gradient of 0. And then at 2 pi, I've got a gradient of 1 once again. Okay, this should look familiar to you, but just to prove it, let's put the graph of y equals cos x over the top. So the graph you're seeing there is y equals cos x. Now this is not a proof, but I think it's reasonably convincing, and it also, I find, helps me to remember how it's going to go, that the derivative of the sine function is in fact the cosine function. So if I just write a little summary here, if I start with my function is sine x, then in actual fact, the derivative is going to be cosine x. So that's sine x. Let's have a look now at cosine x. F of x equals cosine x. So I'll get rid of all that. And just for now, let's hide the graph of y equals sine x because we don't need to look at it. And let's examine the gradient of y equals cosine x to see if we can work out what the derivative is going to be. So I'm not going to sketch the gradients at this point, but if I look at when x equals 0, I can see that I have a horizontal gradient there, which means the derivative function will have a value of 0. If I head over to pi on 2, I can see there that I have a negative gradient, and it's the same shape as my sine function. Therefore, it's not hard to see that this is going to have a gradient of negative 1 when x equals pi on 2. Now I head over to pi, and I can see that my I've got another turning point here, which is going to mean a gradient of 0. So I'm putting a point on pi 0. At 3 pi on 2, my gradient is back to being positive 1. So I'm going to put a point at 3 pi on 2, 1. And then at 2 pi, I'm back to 0. Okay, let's have a look at this shape. It starts at 0, 0, and it goes, oops, I did not mean to do that. And it goes down and up and down. So it's not the sine function. Let's have a look. So this graph, the new graph that I've sketched there, is y equals negative x. It is the sine function reflected in the x-axis. So, I didn't fill my values in here. That doesn't matter. Let's go straight to here. For my function, when I've got the function of cosine x, the derivative is negative sine x. All right. What I've shown you is not a proof, but it's a demonstration that when my function is sine x, the derivative is cosine x. And when my function is cosine x, then the derivative is minus sine x.